Are you sure? Are you ready to start? Yes! Yes! Hello. Today we have a really interesting topic to talk about. And it's known as zero-knowledge architecture. And the question for you, who knows what the hell it means? No worries, I'm here to talk about it. Today we'll define what is ZKA and we'll describe its core properties, and instead of diving into hardcore mathematics, I will show you practical models and practical examples where you can use these in your apps. Okay? By the way, please raise your hands who are iOS developers here, who are Android developers here. So it's mostly, so it's not like 98% are iOS developers and only 4 people are Android developers. Anyways, this is a topic that you can use on any platform, any ecosystem, being honest. Let's start from who am I? Who the hell am I? My name is Anastasiia and I'm a software engineer. I was writing mobile applications for many years, both client-side and server-side, but now I'm switched to the security and I work in a super secret company called Kazakh Labs. And I speak a lot about security, and this talk is just one of the talks I gave. So if you feel that it's too complicated for you, if you feel that you are bored, that you don't like the talk, my style, and kittens, just feel free to go away and grab some coffee. I will remember your face, but anyway, I will try to keep you entertained. And before we start, let's play a game. I'm sure you already know a lot about security, right? Yes. And we don't want to talk about same things again and again. So let's start from the simple definitions. What is sensitive data? How do you think? What is a sensitive data? Any ideas? What for user data? Okay, what is the user data? Private data. Can you name some examples? Personal code. Yeah. Sorry? Driving license number. Okay. Usually people start from medical data. Usually people start from name, surname, passport number, but yeah, you're right. Medical data, driver's license, passwords, passports. Basically, sensitive data is everything you want to keep private. It can be everything. It's subjective for us, for any of us. And the problem is how to define sensitive data, and believe me, the problem is how to protect sensitive data. The next question is, what is E2EE? Okay, what it means? Tip for you. End-to-end encryption. Do you know what is end-to-end encryption? Yes. Yes, raise your hands who has heard this before. 1, 2, 3, 4, 5. Yes, you're smart. It's super easy. It's super easy concept that the data is being encrypted on the ends. Usually we are talking about clients. In our case, clients are mobile applications. So the data is encrypted on the end and can be decrypted only on this end. No one in between, no server, no network can decrypt the data. Okay? End to end. Let's move forward. GDPR. Who knows what is GDPR? Just raise your hand. 1, 2, 3, 4, 5, 6, 7. Poor people. GDPR is General Data Protection Regulations, and if you know it, you are probably working in European company and you probably have some difficulties in implementing security in your applications, right? GDPR is a standard by European Parliament that defines what is a sensitive data and how to protect it. And it demands data controllers, we basically in our companies are data controllers, to implement data protection by design and by default. These regulations, they define a set of fines if your company doesn't implement any kind of protection. And GDPR will be active starting from May 2018. So it's like several months. Okay, moving forward. Equifax. Do you know what is Equifax? The story behind Equifax? Yeah? 1, 2, 3, 4, okay. 3, 5, okay, almost 10. So Equifax is a credit bureau, and they had a massive data leakage several months ago. What information do usually credit bureaus have?
Social security.
Yeah, a lot of private information, name, surname, social security number, passport number, driver license. All the data was leaked. It basically means that other companies, that you or attacker can use this data to pretend being those Equifax users. This is really, really bad. Good. You are doing good. You deserve a kitten for all your efforts and for your knowledge. Let's move forward. We all have sensitive data, but what do we do with it? We put it in the cloud. Do you know what cloud is? Is it a magic place? Is it a portal to another universe that guarantees data security?
Yes.
No, not really. It's just a computer. It's somebody's computer that runs on somebody's software and is being maintained by someone else. So, in fact, we have sensitive data and we put it on somebody else's computer. Important questions. Do we trust them?
Sometimes.
And what is the more important question, do we want to trust them? No, not really. We don't want to trust them. We don't want to know how secure this cloud is. We don't want to read their policies. We don't want to check their SLA. And of course, we don't want even to think what will happen if or when this cloud will be hacked and all our data will be leaked. We don't want to think, we don't want to trust, we don't want to know everything. What do we want? Candy, yes! We don't want to be like these kittens. Just small kittens sitting in a tin foil hats. They know nothing about clouds, they know nothing about security and sensitive data protection. And they don't want to share anything. Who wants to be like these kittens? I want to be, yes, yes. And we don't want to share anything as well, right? Not because we have something to hide, not because we are paranoid, but because we choose not to share every single detail of our private work life. But sometimes we must do this. Do you know what common do your medical history and your credit history have?
You take loan for operations.
You take what?
Take loan for surgery.
Yes. Talking about data perspective. Well, basically, both these examples are examples of data that you share to someone. So you don't want to share your private data, but you do. For example, you want emergency doctors to have access to your list of allergies, to your list of surgery, to your x-rays, right? But you do want to share this information only to some doctors and on some particular cases. So basically it means that we want to control what we share and whom we share. We cannot trust by default, and we don't want to think about security all the time. So we choose to retain control over sensitive data while we store it and while we transmit it. The question is, how? The naive answer is encryption. It's rather easy. Encryption helps us to solve problems for some specific use cases, and of course it creates new problems as well. You know a lot of examples of using encryption. For example, in messaging, we use end-to-end encryption. As we talked before, apart from the clients, no one should be able to decrypt the data. Clients have means to verify trust to each other and to the server, and to ensure that cryptographic protection is working properly right now. End-to-end trust without leaking a secret over in a storage or over transmission is a base of zero-knowledge architectures. And I'm sure that you already know a lot of examples of end-to-end encrypted messaging applications. Can you name some of them? Via Telegram, yeah? WhatsApp. Talking about Telegram, I would say Telegram secret chat, Facebook Messenger secret conversation, WhatsApp Signal. Yes, there are a lot of them actually. Questionable, right? Let's talk about authentication. In authentication, we have interactive crypto protocol, a set of protocols that are known as zero-knowledge protocol. Have you heard about them before? Zero-knowledge protocol, ZKP. No? There is a link for that. Actually, after the talk, I can describe what it means, just not to spend time like right now. But basically, the idea of the protocol is that you can compare a secret between two parties without actually sending this secret over the network. So you have a set of rules how to make sure that both parties have the same secret, like the same password, for example. But you don't share it, you don't send it. It's an interactive protocol based on answers and questions. It's really easy, it's based on mathematics, and it's being used in many systems, maybe except mobile. But we will use it sooner or later. No. Okay, let's dive into explanation. Imagine that you have a password. Let's pretend it's a string, okay? Let's pretend it's ABCD string. And you have a client and a server. Each of them has this password. It's not a password, it's a secret, but however. So instead of sending it over the network or sending a hash over the network, one side client asks server side, can you please take the third character, the ASCII code of the third character, divide it by 3, and multiply by 10 and send the result. These parties do these computations and send the result. This party is doing the same computations and checking the result. Okay, but one check is not enough, right? Strings may be just a coincidence. Strings may be not equal. So this party, second party, asks a question to the client, saying, hey, okay, can you please take 10th character plus 7th character, multiply, divide, blah, blah, and send me the result back. So they are doing this interactive Q&A, one with each other. Usually 6 to 8 questions are enough to ensure that 99.999%, we are sure that by this amount of persons, their passwords are the same, the secrets are the same. This is how it works. It's super easy from understanding perspective. It's a little bit tricky from mathematical perspective because honestly, it's not just multiplying and dividing, okay? And of course, it requires additional sets of network calls when we're talking about real application. But details are there or after session. We talked about messaging, we talked about authentication. What about data? We want to share secret data and we want to have something more than peer-to-peer relationship. We want to store it encrypted and to share it to some users and to manage access, but we want to do it in a really simple way, like kittens. If the server is hacked, if the operator is dishonest, nothing can happen because data is encrypted. We just say meow and move forward. We feel safe in this kind of system. Now we got to the zero-knowledge architectures. Basically, ZKA is a design principle, is an architecture. And in a simple words, in ZKA system, everything is encrypted before it gets from the client to the server. And the key of encryption is also never known to the server. First important layer of ZKA is end-to-end encrypted clients, as we mentioned before. The FAT clients, because you need to do a lot of cryptographic computation on the client. And server knows nothing about the nature of the data. Sometimes zero-knowledge architectures is known as no-knowledge architecture, because no one in between knows nothing about what this kind of data. It just encrypted, something encrypted. Second important basic base of ZKA is that all operations are being made on encrypted data. So you have a database. If you want to add a record, you add it encrypted. If you want to update the record, you update encrypted record. If you want to share the record, you share it encrypted. If you want to search through the data, you search through encrypted data. Do you know, it might sound tricky, but there are at least two ways how to search through encrypted data. Can you name at least one of them? Okay, I'm here to do that. First of them is so-called homomorphic encryption, and the second is symmetric searchable encryption. So if you encrypt data in a particular way, you can search through this data. Of course, you are searching not a plain text, you are searching a ciphertext as well. So you search encrypted piece in encrypted data. Let's move forward. ZKA is not rocket science. It's already solved for many specific use cases. For example, if you have a large document and you want to share it to some users, the naive approach is to encrypt this document with key of every user. So let's say we have 5 users, we generate 5 keys, we encrypt the doc with this key, and we share 5 different encrypted blocks with keys to our users. This leads to data duplication, and what is more important, if you want to update the original data, you need to re-encrypt it and resend it. Does this sound like ZKA? Yes. This sounds like zero-knowledge architecture, really. Does it sound easy? No. There are better approaches how to manage encrypted data. For example, you can split data into blocks, and you can divide the data blocks from access blocks. So accessing or encrypting or re-encrypting only what you want and when you want. If you want to change the data, you change the data block encrypted, but you don't touch the access block. If you want to revoke access, you just touch the access blocks, but you don't touch the data itself. There is an implementation of this approach by Z-Link. This is an open source library that will be available by Z-Link soon. It's not released yet, but it's designed to solve this kind of problem. Okay, why should you care about all this complicated stuff? Because unfortunately, we are not kittens. We are mobile developers, and we need to run cryptography, and this requires trust to the device. And we use these nice shiny mobile devices and create these nice and shiny mobile applications. And mobiles are quite trustworthy. It has environments that may have more trust than desktop or web. Of course, it's not still entirely secure. If you jailbreak or root your device, you should not trust the code. However, mobiles have things like secure enclave or keychain. Of course, you can put your keys as a string in your source code. But anyway, this is all about risks. We are the best people to implement zero-knowledge architecture approach and to protect our users, just because our users are generating sensitive data on our devices. I know that you are excited about all these theoretical things. I see it in your eyes. Let's move to the real world examples, okay? Ready? So, moving to the real world. Imagine that you're a cat. That's easy, yeah. But you live in a cruel world where cats have a credit history. I made up this JSON myself. It's not really readable. Just trust me. It's based on the real credit histories. And it contains of blocks. First block is a personal data block. It has your name, surname, home address, pet's name, etc. Banks, credit bureau, and other companies are using this data to identify you, to make sure that you are you, or in our case, that Mr. Cat is a Mr. Cat. The second block is a credit rating or credit score. This is something you want to keep protected, because based on this rating, banks decide whether you will have a loan or you won't, whether to approve your loan or to reject it. And the third block, this is a history of your transactions with other banks. You really want to protect it hard, because it reveals a lot about you and about your lifestyle. So, this is a scheme of relationship of Mr. Cat, bank, and credit bureau. Who has credit history of Mr. Cat? The credit bureau. Now imagine that Mr. Cat goes to the bank asking for a loan. Bank gets this identified information of Mr. Cat, name, surname, SSN, passport number, etc., and sends to the credit bureau asking for a credit history and a credit score. Bureau sends the credit history back to the bank. Usually, bureau stores the whole file, so they just send the whole file back, although bank doesn't need to have all these transactions. But sometimes banks ask for more data than they really need. And of course, that bank is not the only one bank in the life of Mr. Cat. There were other banks that Mr. Cat dealt with, and they also asked for credit history in credit bureau. And of course, credit bureau shared credit history with them. So look on this scheme carefully. Mr. Cat's credit history is being circulated through different entities. What could possibly go wrong? Well, a lot. First of all, if or when bank is cracked or credit bureau is cracked, Mr. Cat's data is available everywhere. And of course, credit bureau can encrypt the data, and usually credit bureau do encrypt the data. However, they use simple symmetric encryption and store key near the data, so when key is leaked, data can be decrypted, and actually this simple encryption makes no sense. Next, dishonest credit bureau or banks can accumulate more data than they should. That data they can misuse against Mr. Cat. For example, as I said before, banks can ask for the whole credit history of Mr. Cat last 10 years instead of looking only on the latest records. Next, banks are judging you or Mr. Cat based on knowledge they accumulated without your consent. For example, credit bureau has this access to the transaction history, so credit bureau knows where Mr. Cat went to which banks has rejected him, and credit bureau knows how desperate is Mr. Cat right now and can change its credit score. Not because it has this information primary, but because it can calculate this information based on the private data of Mr. Cat. And The last one, if you remember how bank asked a credit history, they send your SSN, Social Security number, over the network. They leak a piece of your personal data over the network, and even if Mr. Cat is not a client of this bank, the SSN number is already leaked, and credit bureau is accumulating all the data. So next time it knows a lot about Mr. Cat. How we can solve this kind of situations using ZKA? First of all, we can split our data to blocks. Basically, it's already splitted, but we can split the access to the data by blocks. Your personal information can be available read-only for the banks. The credit score is available read-only for the banks and read-write for credit bureau. And of course, transaction history. We should allow banks to change only the latest transaction, this transaction history, to have read-only access to the next one or two transactions, and we don't allow them to see it all. This kind of data control should be done by data owner, by Mr. Cat. Not because bank asks credit bureau for the whole history, not because credit bureau stores everything, but because Mr. Cat allows access to this kind of data. Again, the data should be encrypted. It should be accessed by blocks, and the access control should be controlled by data owner, by Mr. Cat. Let's take a look on the scheme, how it has changed. Still, credit bureau is storing the data, but now it's encrypted. So if credit bureau is leaked, at least the data won't be leaked in a plain text. Then each bank has own key to the block of this data. And of course, access can be revoked. So if Mr. Cat is not working with some bank anymore, he just revokes the access. How to build this kind of system, how it works? As we mentioned before, you should decouple storage keys from access keys and encrypt data using storage keys. Control access by access keys. Put storage keys in containers. Control cryptographically that user can change storage keys by comparing actual ownership tags using HMAC, for example, to prove that they can perform this kind of operation. Then, since data is available only in encrypted form, you should design your system, your architecture, in a way that no one can pass your crypto core. No one can put data in a plain text to your database. And of course, you should remember that cryptography is not a magic wand. It won't solve you everything. It just narrows the attack surface. You still need backups. You still need to use zero-knowledge proof protocol to protect against replay attack, for example. You still need to ensure code trust. Don't trust jailbroken devices. You still need to secure key lifecycle, because if you put your encryption key in a plain text somewhere, all your efforts are kind of useless. And a lot of other things. Thankfully, there are high-level libraries to solve these issues. How does this help Mr. Cat to handle risks he's suffering from? Data leakage. As we said before, data is encrypted. Privileges escalation. Do you know what is privileges escalation? When you have a database, they usually, what databases do you use? MongoDB? SQLite? Postgres? Okay, have you heard about MariaDB? Cassandra? Any other databases? I'm just asking. I just see your faces. I'm just asking. So the privilege escalation. Let's go back. The privilege escalation. You have a database and you have an access control list, right? So your users has some kind of role, read-only, write, admin. if you hack a server where you have this database, if you have a root control to the server, you can hack the database. You can escalate your privileges, the privileges of your user, through hacking the server itself. Okay? So, how ZKA helps us against privilege escalation? As soon as we don't have ACL in this model, we have access keys that are based on cryptography, that is based on, this is basically a crypto keys. Hacking server doesn't allow you to escalate the privileges. What about replay attack? How to avoid accumulating secrets? You can use zero-knowledge proof protocol, as I mentioned before, without sending a secret over the network. It can be leaked. You don't send the secret, it can be leaked. Easy. As for other things, there is a set of traditional tools like monitoring, logs, intrusion detection, traffic inspection. I'm sure you use all these kind of tools, right? Yes, yes. Do you use logs? Do you use logs from your mobile application to the server somewhere so you can read those logs? Do you read those logs? Do you monitor weird activity? Like, if your application, do you know what is a poison record? Or poison marker? It's off topic, but I really like this thing. If you have an app, and you, for example, you want to protect your app from being cracked, you are using some keys to connect from your app to the server, and you put this key somewhere really, really deep. But you create so-called, like a honeypot. You create something that is being visible for attacker. You name it my secret key, and you put some string here, poison record, something. And you monitor your logs. And if you understand that someone is using this fake key to connect to your server, it means that someone right now is trying to hack your app. Okay? Yeah, I know, it's a nice technique. I really like it. It's more about social engineering than cryptography, but okay. Let's wrap all the things. We have seen really nice examples of using ZKA with cats and credit history, but of course it's not the only one existing examples. Where you can use this kind of approach with documents? Actually, anywhere when you have large documents that should be shared to many people, and preferably it should be shared by blocks. It can be complex documents with comments, spreadsheet. It can be online document like Google Doc or something like Dropbox paper. Of course, the databases. Databases are really nice example of a large document splitted by blocks. Next one is file systems. File system also is something that has a tree structure and something that you are controlling access to different blocks to different parts of the system, to different files. If you have a large configuration file for your continuous integration, for your server infrastructure, you don't want everyone to be able to edit this file, right? You want to control access, you want to give your team member ability to change configuration only for one servers, another your team member to change configuration for other services. Maybe maybe this is an example from DevOps Live. We're on mobile conference, right? Okay. Anyway, how difficult is this to implement? How do you feel? I see your faces. How do you feel? Is it difficult to implement?
No.
Depends.
How key management could be different? How those if you have two secrets and on different devices, how you deploy those secrets or files?
Yeah, actually,
Key management, this part looks like most challenging.
you are 100% right, because there is a known phrase that encryption is easy, key management is hard. Even if you put a lot of efforts on encrypting all the things, if you put your keys in a plain text, and again, if your system is really complex and you need to send keys over the network, the question is how to do it in a secure manner. But going back to the implementation of ZKA kind of systems, this is just a start session code from Axolotl. You know the Axolotl, the protocol that is being used in the Signal. This is a totally custom implementation, their vision of how ZKA should look like. And it might look really long. You don't need to write all this code. There is a lib for that. Another example, this is my code written using the library called Themis. This is an example of client-server end-to-end encrypted system. It just based on high-level security library. You don't need to write all the cryptography yourself. Another one, and of course it's easier to read. Another one, a tool I mentioned before, tool that is being created especially for the use case of large documents with a block and access control, is known as Hermes, and it also will be available on GitHub, free to use. Of course, there are other implementations. You may heard about LAFS. LAFS, or Least Authority File System, is a storage, is a cloud storage that takes your file, separates it by chunks, and sends to the different servers. Encrypted, of course. Then if you want to read the file, it grabs it from different servers, decrypt, make it a single one, and sends to you. Actually, it's being made on your client machine, so no sending of plain text information over the network. If you use CareKit, who have tried to play with a CareKit? Okay, who are writing the medical application? Any kind of medical applications? Anyone? Just raise your hands. Anyway, if in one day you will decide to write a medical application and you will decide to create integration with a CareKit, there is a lib for that. There is so-known ZeroKit, a tool for authentication, especially created for medical apps. You can check it by that link. Good. You are still here. You deserve another kitten. Let's summarize all the things, okay? ZKA, or zero-knowledge architectures, or no-knowledge architectures, is a design approach. It solves problems of trust in the server, trust in the transmission environment. It's rather easy to solve when interaction is simple, when you need to share only one block of data to only one user, and it gets really impossible when we're talking about databases or collaboration. Of course, it's not impossible at all. I have shown you some examples of solving everyday problems if you're a cat, and solving other problems if you're DevOps, if you're working with a database. And the thing is that users are collaborating on the data, and they will collaborate on the data more and more every year. Even if your application right now is single user, is made for only one user to generate the data, maybe later you will add the ability to collaborate, you will add the ability to share this data to someone else, to create, to use the manpower to create some cool things. And then, on this moment, you can remember that, yes, I want to secure this data. I want to protect my users because it's me, mobile developer, and it's my responsibility to protect the user's data. And I know how to do it. I know that it's not super easy, but I know that it's not super complicated. I know where to Google. I know which words to Google. I know that there are existing implementations and that I can use. Right? Yes, yes. I know the winter is coming, and I know that you prefer to sit somewhere on a sofa and to read long security articles. I see it in your eyes again. Yeah. So I have prepared, knowing this desire, I have prepared a list of links for you. It's this kind of list. This list is being specialized on zero-knowledge architectures. So about zero-knowledge architecture, about zero-knowledge proof protocol, and list continues. About already existing systems, about already implemented systems, because we are not the one. Zero-knowledge architecture approach is being used in web since 2007 at least. 10 years. And of course, about end-to-end, if you still don't know what it means, there is a nice article, Explain Me Like I'm 5. End-to-end encryption and zero-knowledge proof protocol. Good. All these slides and all these links will be shared, so you will be able to press on this. If you feel that this talk was too complicated for you, maybe you have this feeling. If you want to dig into code, if you want to read some more practical examples for your current everyday life, you can check my other talks. One of them is about key management. Key management, how to store keys, how to rotate keys, what is a honeypot, poison records, all the things. Some of them are about really simple ideas of transport encryption, SSL pinning. Please raise your hands. Who has implemented SSL pinning in your app? Okay, like a third, probably? Good. I told you know a lot about security. Thank you a lot. If you have any questions regarding your particular application or your particular use case, can you please ask these questions like one-to-one? Okay, because usually it requires some time to dig into to understand the ecosystem. If you have any other questions about the zero-knowledge proof architectures, about how to build this kind of system, feel free to ask them now. If you are too shy, yeah, I see. If you are too shy to ask them now, feel free to ping me. Twitter, Gmail. Okay, not many ways to ping me. At least use Twitter. Huh? Phone number? Sorry. Next time. Thank you.